It's funny, we were having a conversation before this, and I feel like we could just talk for hours and hours about our passion for Earth. So I was thinking about why Earth is important now as a construction material. And I think if we think of the urgency that climate change presents us, I think it's important for us to start looking at alternatives to the way that we build things, because the way that we do it now is toxic and bad for the environment. And Earth is a material that's ancient, but it has benefits that I think could really benefit the way that we live today. So some of the things, it's beautiful, natural, sustainable, fireproof, mold-proof, soundproof, bulletproof. It can augment the energy efficiency by providing thermal mass. It can be hygroscopic, so it can help regulate humidity, which is something we were talking about earlier. So there's so many reasons why it's such a wonderful material. But I think because it's such an old material, there's a stigma against it. And people are afraid to embrace it. They don't understand it. But I love it. I know that you love it.
Oh, yeah.
So do you want to talk about why you love it?
I love it because anytime I've got a conversation in depth with people in the architecture business, a lot of times conversation comes around to the connection or disconnection between where we are and the materials. You know, if you know anything about biobiology, which is a German philosophy behind life and living, they feel that we've got essentially three skins. You know, we have the skin that you can touch here, we have the skin that's our clothing, and then the third skin is the buildings that we are enclosed in. And so it's easy to be able to find materials that are good for the second skin, as far as, you know, cottons and natural ingredients like that. But when it comes to the building envelope, there's like, what? You know, there's not a connection. A lot of people feel like it's important to be barefoot all the time. Some people actually have something that they wrap around their leg at night and they connect into the ground so that they can be grounded to the earth. And biobiology is about that. I don't know if there's any scientific studies done, but there is a connection that some people swear that is between the way our molecules work and what's going on in the earth. And so whether it's true or not, it's a great idea. Let's go ahead and see if we can take care of that. And so that's one reason why I'm excited about Earth. Another reason is, like Beth was saying, it checks all the boxes, you know, and it's ancient. It's been forever. It's like the first materials, you know, apart from carving out a cave, we used for shelter. And so when you start talking about earth and construction in the 21st century with anyone, in America, a lot of it is like, well, that's new stuff. You know what? I don't know. I'm kind of afraid of new stuff. Well, no, it's not new stuff. It's been around for 6,000 years or more before they were actually writing down things about stuff there was. And I'll ask a question sometimes. I'll ask you, what is the oldest continuously occupied structure in America? Can you think? You know, and it's actually probably, arguably, Taos Pueblo, which is at least 900 years old, and some people say it goes back 1,100 years. And there's no air conditioning in there. You know, if there's any repairs, they just patch it with the soil that they used to build it in the first place. And so it's not only not a new material, it's not a difficult material. And so it's just a matter of what Elizabeth and I are doing is telling everybody we can about, you know, the attributes of it. Don't be afraid of it. It's only soil. So it's easy to work with, and it's all those things that she talked about earlier. All right. This is a sheet that I did for a presentation I did last year, kind of helping people understand the history. You know, here's kind of a timeline. I know you can't see that, but you know, Taos is down here, and here we come up here, where we have the Industrial Revolution and what was done with home building in the United States after World War II, when they found a mass production way of making houses. And we went that route. That's the route that we chose to go. And the codes were driven by what the builders were doing when it came to the attributes of mass production of houses. And mass production of houses is leading to a lot of shortcuts a lot of things that make home building extremely competitive, and mass production, you only see that in the real estate section and the home tours. You feel like you don't have a choice. You know, you've got this box and you've got the two huge garage doors, and maybe the main person door is tiny, or it's even on the side of the house, and it's like the focus is all wrong, you know. And it's made with materials that are expedient, cheap, and toxic, unfortunately. And there's not really anyone in the federal level who's looking out for how to regulate toxins. Like you've seen BPA-free plastics. Well, that's nice, but they don't tell you that they're using BPA-B as the substitute, which guess what? Is probably just as toxic as BPA. And they don't have to tell you that because the government doesn't tell them that you have to tell them that. So, matter of fact, the organization that is tasked with determining toxicity and safety of materials is still working on asbestos. Yeah, a lot of people don't know that. A lot of manufacturers say, I'm not going to use asbestos because we know it's bad, but there's not a regulation that said you can't. And so, and that's asbestos. It's not the other 50,000 chemicals that are out there that do God knows what. And so, if you're using earthen materials and you're careful about what you're doing for your flooring, your cabinetry and carpeting, and God knows, don't use flame retardants in anything because that's really, really nasty stuff. But you really need to, architects for sure, and then as we go toward builders and toward eventual consumers, really need to know about this stuff, and most of us just don't. So that's another reason why this is something we should be taking care of. But it's old, it's very adaptive. That top picture there is what they call Manhattan of the desert. It's in Yemen, and it's like 7-story tall earthen construction. And I mean, it's modern enough. If you see a picture of that at night, there's lights. You know, they've got sewer facilities. It's like a regular city, but it's made of earthen construction. And it can be beautiful too. This is a mosque, also in Africa. Africa gets it. In Palestine, and across North Africa and into Spain, you know, when the Moors kind of ruled that part of the world, they really developed earthen construction and developed adobe construction. And in 1492, when Ferdinand and Isabella kicked all the Moors out, that was the same year, of course, that Columbus came over here, and they started coming across the United States and using earthen construction differently in different climate zones as they were going from east to west. And a lot of that still appears. You can see some of that in the mission architecture in San Antonio, for example, and it's very interesting stuff. So a few centuries, well, decades later, the European influence in Northern Europe after the American Revolution came down and brought in heavy timber, and then the Industrial Revolution gave us mass-produced nails and that sort of thing. So we decided to go a different route. So it can be contemporary. So we have one more slide?
Yeah, we have 2 more.
Okay. So these are the kind of things that you can do in earthen construction now, because when you say earthen construction, to a lot of people, they think, oh, Santa Fe, Adobe, and that's it. But not necessarily. This is a house built by one of our friends in Colorado, and it's just as contemporary. I mean, I wouldn't mind living in the house. You know, it's just fabulous. And here's a rammed earth house too. This is a structure where there's formwork, and they put earth in between the forms and pound it into place, and it comes up with a very, very, very durable and healthy house.
Yeah, now this one, and actually I'll show, these are rammed earth, really lovely, really beautiful.
Can you see that?
And this one actually, it's a compressed earth block veneer. So it's a 6-inch block on the outside of the house. This is a house out in Marfa, Texas, by Dust Architects. And as you can see, it's actually hasn't been, doesn't have lime plaster on top of it. It's just the exposed earth, which they did stabilize. We do stabilize the blocks. Do you remember what Dust used to stabilize their blocks? Was it cement?
I think they use cement. I'm not
think,
100% sure, but it's just low percentage.
Yeah, it's a very
Yeah,
low
so-
percentage. It's usually 6% or something like
Right.
that. You can also stabilize blocks with lime as well. But I think the process to do that is a little more involved because you have to take into account the pH of the soil to know how much you should put in lime. And so it's not as common to use lime, but it is even more sustainable. And the reason is that lime, as it cures, absorbs carbon. And so it helps to mitigate any carbon that was emitted during the manufacture of lime. And there is a man out in, is he in Kerrville? I can't remember his name, but he's making lime blocks, CEB out of lime. Have you heard of him?
Yeah, that's Brian, right? Brian
Yeah,
Colley?
I think so, yeah. And both Stephen and I are designing homes right now out of CEB, out of earth. I have a couple of clients from the town of Superior, Colorado, which is a town that burned down, I think it was last year, and it burned down in minutes. Like it decimated the whole neighborhood. It just went down like matchsticks. And so the clients there are wanting to rebuild. Insurance companies are saying, okay, we'll give you money to rebuild. But obviously they don't want to put another matchstick house up. And so right now we have 2 clients that we're designing CEB homes for. And it's a fireproof wall system, which is kind of incredible. And then it's healthy for you. It's like if you're inside of it, there's a certain warmth to it, and then if it's, as long as you don't put too much cement in it, it is hygroscopic, so it helps regulate humidity, which makes a room more comfortable. There's so many reasons why it's such a wonderful material, but I think it's our job to help people not be afraid of it, because the first thing that people ask me usually is, well, how does it weather? Is this going to melt on me? Is it, when it rains, is it going to fall apart? But there's things that we do to stabilize it so that doesn't happen, obviously.
Yeah, a funny thing too is people say, so it's successful all the time. And no, all these examples that you see that are hundreds and thousands of years old, those are the examples that worked. I'll be the first to tell you that if something didn't work, they had the mix wrong, or maybe the walls are too thin, they fell down and they went back into the soil and they just said, okay, we'll try again. So it's not foolproof. It's not rocket science, but it's not too damn tricky either. And so that's one thing that the ECI, the Earth and Construction Initiative, is doing right now. We've got a grant to do a study on materials, which hasn't been done in America yet. And we're going to go from there to making a study on the hygroscopic aspects of it, so that mechanical engineers can take a look at how it deals with humidity and temperature to resize and reevaluate what the requirements is for air conditioning. And so that's what ECI is doing from the ground up to do that sort of thing. And we were kind of skirting around the thing about concrete as a stabilizer. Reinforced concrete, we're surrounded with here, there's a lot of really good examples, and they're using a lot of it. The Portland cement component of reinforced concrete takes a lot of energy to produce. There's rotating kilns. And if you talk to anybody who knows about earth science or even climate change, they'll say, well, a lot of the carbon pollution, a lot of the carbon dioxide goes in the atmosphere from concrete production, specifically Portland cement. And so that's why we're minimizing as much as possible the amount of Portland that goes into our structures that we design. And it's just a matter of time. I was telling Elizabeth earlier, 100 years ago, the concrete industry was just getting started, and they didn't have code books yet. They didn't have the recipes all worked out. And they were doing with concrete what we're doing today with earth. What works? What doesn't work? What do we add? And so that over time, probably not my lifetime, we'll be able to have the same kind of materials code books for earth and construction as we do for concrete. So that's what we're going for. And so we can actually highly minimize the embodied energy that goes into our structures. It's one thing to be net zero occupation, where you can put solar panels on a house or a building to produce as much energy as that building is producing. But what about the amount of energy it took to build the house or building in the first place? And so that's the holy grail. That's what we're working for.
Yeah, from beginning to end. So even the people who are constructing and building can benefit during that process as well.
Right.
Yeah. So for me, it's really exciting to be involved. Like Stephen said, we're kind of at the beginning. Where concrete was 100 years ago. So we're experimenting and we're trying different things, and we build one house and then we learn from it, and then we figure out what to do better for the next one. We're speaking to the structural engineer even about the way that we insulate, and maybe we'll have these back and forth conversations. Well, maybe we can put the insulation here, maybe it's on the outside, maybe it's on the middle. We're trying to eliminate thermal breaks. Where cold air or hot air can get into the house, and it's so exciting. It's the one place in architecture where we can have those conversations, because with conventional construction, that's all been figured out.
Yeah.
But with earthen architecture, even though it's ancient, to transfer it to a modern, something modern that we use for the masses now. It's something that hasn't been figured out, that we are figuring out. So it is, for me, it's just so much fun to be involved. It's like I'm really excited.
Oh, me too.
Yeah. And this is one fun project that we did. So this is a compressors block shed. So this is Dan Leroy, he's the owner. James Anthony is a Bovedero, and he builds these. He builds domes without using formwork, which, if you know anything about building domes, the expensive part of it is the formwork. So if you can build a dome without using formwork, it's kind of an incredible thing. And I remember doing research when I was in school and talking to a professor, and we were talking about this idea of learning from Bovederos and making domes without formwork. And he's like, how do you know what to follow? And I was like, well, I don't know, but they're doing it. So obviously it can be done. And I think the science behind dome work is a little bit of like, it's magic. It's a little bit of magic happening. And math, magic math. But so he built this, James used compressors, earth block. We put
Bottles.
Glass bottles. You can see them along the inside there, and then glass blocks that, you can see one over there in the corner. But he built it using you see this piece of wood? So it was on a pivot, and then we would kind of just pivot it around, and he started the blocks, the outside course first, and then the second course, and he would just pivot that formwork. It's not a formwork, it's a guide, because it never touched the blocks. So it had to be free moving, but there was never more than a 1/4 inch between the guide and the blocks, and it just got built. And at the end, he put a skylight right in the middle, and they're standing on it, as strong as can be. So you could the point of this is that you can even make your ceiling out of compressors blocks. So you could be surrounded by a natural material.
I'm curious, because obviously to me this is like the Pantheon, right?
Yeah.
How much is your work informed by ancient practices? Because obviously the Romans are doing all this stuff.
Yeah.
The Greeks and,
Oh, it is. It's absolutely informed by, we look at things and we know what's possible. And I even think, we look at it, and I think engineers probably would look at it mathematically.
for like concrete and different bricks that they used to make and things like that. Is that something that you guys look at? Or
I think those formulas are kind of lost to history a little bit, but I think so, right?
Yeah, the Pantheon. Interesting you mentioned that. They were using concrete techniques that disappeared from history, disappeared from knowledge during the Middle Ages, Dark Ages, and the plagues and all that. A lot of that was forgotten about until maybe the middle of the 1800s when they rediscovered things again. And like I said, 100 years ago is when the concrete industry, took it and actually made it much more definitive. In earthen construction, like I said, we're just getting into that. It's primarily clay, sand, and silt. How much clay and what proportion? And clay, there's about 350 different kinds of clay. And a lot of people don't realize that. Sand too, whether there's kind of rounded sand, like imagine river rocks that are rounded that are tiny, and then there's very granular that looks like salt or something. So the sand that you choose makes a difference too. And so we're figuring that out. As far as the math and the domes and stuff, my favorite is the catenary arch. If it's like the St. Louis Gateway Arch, what you do, take any kind of string or coil or anything and hang it, that is the perfect structure. If you were to solidify that and turn it upside down, you've got that catenary arch. And that's the most clean structure you could use to determine the kind of weight and distribution. It was Anton Gaudí did the church La Sagrada Familia, if you've ever been to Barcelona. He built a model using chains and weights that conformed to where the structure was if the whole chain thing was upside down. And so a lot of his columns aren't even straight because the model, they weren't straight. It's just extreme genius as far as design goes. And so we'd like to be able to do that sort of thing. But also simple works. I was involved with, I didn't produce, but I was a member of a dome workshop in Terlingua about, oh my gosh, it's been about 15 years ago now, where the dome was measured by taking a 2x6 across the 10-foot span. In the middle, we put a hinge that had only one screw in it. And then we screwed that hinge to another 2x6. And so this 2x6 was able to go around 360 and up and down, 90. And so any point at the end of that device was the same distance from the center of where the hinge was. And it was easy to put a little block on that and say, okay, this block goes here, this block's gonna go there. And we had this dome done in about 3 days. And so it can work. A lot of things in between Gaudí and what we did. So.
Yeah, I think that's a great example. So the way that I understand the catenary arch is that if it's hanging, that's a tensile, that's pure tensile strength. Mm-hmm. And if you flip that around, it's pure compression.
Yes.
So it's just as strong as the strongest, and there is the strongest shape that it can be. So you can kind of create different shapes by moving the string in different configurations. But there's an organization in Germany that studies dome mathematics, and I think their name is Block Research Group. But they've come up with software. It's called Rhino Vault, and use it with Rhino software that comes up with perfect compression shapes, and so you can kind of mathematically create domes using their software. But they also, what they've done is to be able to test or mathematically test or configure, I'm not sure, I'm losing my words, but ancient structures and calculate why they're not falling down. Right?
Oh, wow.
So I
Cool.
think that's really interesting.
Reverse modeling.
Yes,
Yeah.
yeah.
Great.
So I have a question. This house in Colorado, do you try to use the earth from the side, or where do you?
If we can, yes.
That part of it, because I know that would alleviate some carbon footprint.
Yeah.
Moving around.
If it's possible to, yeah, I think the earth for this was taken from the site, for the one on the left. But the company that I work for, their name is Colorado Earth, and they have their own space where they have a pit where they dig the clay and then they transport it. Because not every site is available for digging out earth, because it's a lot that you have to dig, and not every clay or soil type is appropriate either for a building with. I think more non-smooth, I don't know what the opposite of non-smooth is, but smooth shaped clay is going to be stronger because it locks in as it compresses, for example.
Yeah, like the sand.
Yeah.
Same thing.
Yeah.
Usually it would be ideal to be able to get the earth from your building site, but it isn't always the case. And also you'd want to take that soil and find out, do some compression tests and things to see if it works. But there are quarries all over the place, and you don't usually have to go very far to find, sand and clays, especially in Texas. where that's just like you can't throw a football without hitting a clay pit. It's
Yeah, that's
it's
true.
phenomenal. And so some places are starting to think about putting batch plants together, like the one in Colorado that she was talking about, where they will actually make the blocks and ship those. It's right, it is a embodied energy aspect, but on the whole scale use construction and of it's a small percentage, the transport.
Everybody's talking about the fact that we can continue building concrete and it's going to be available safely.
Well, that's the funny thing. When I first heard about the sand shortage, I was going, "Oh no, not that!" So we're always chasing something. We're always finding a way to deal with something. And yes, there's certain parts of the planet there is a sand shortage where they're actually having wars about it. And there's all sorts of, well, not full-fledged wars, but some really awful regional conflict over sand. Yeah, you would think that, oh, that's absolutely everywhere. So we have to deal with that. It's like with anything else. I mean, we're dealing with earth and construction, dealing with the whole thing about Portland cement and other things too. So it's just another thing we'll have to address and just keep an eye on.
Say like this took off and everybody wants to do their thing. Have there been kind of any ethical conversations about conservation?
Nothing has come on my radar. Have you heard anything about conservation of resources with earthen? Interestingly, I hope that they don't tear down a rainforest to get to the soil underneath. But the source material for earthen construction is usually gravel pits and things that are already being industrialized for extraction anyway. And I've never seen any kind of organization yet that says, "Oh, save our gravel pit."
I do think, I think there's, that would definitely be something the gravel pits companies would hopefully be addressing. I visited a gravel pit. When I was studying, we visited the place where we did some studies when I was in school, a student, and we went to the gravel pit. I can't remember their name right now. Silver Mountain, I think. They're out of Fort Worth. They're not too far from here. And they drove us around and showed us all the pits and all their big, excavation holes, and they talked a little bit about what they do, and a lot of their practices were really interesting, really cool. Like they had pumped. I guess it was Eagle Mountain Lake was having a silt problem, and so they actually pumped a bunch. They have these big holes after they dig all the ground out. They were filling them up with the silt that they had pumped from Eagle Mountain Lake all the way to the gravel pit. And I thought that was a really great, interesting thing that they were doing. But another thing they're doing is because once they have these big holes, they're throwing stuff in them to fill them up. So they're throwing tires, they're throwing those recycled plastic, things that hold sodas. They're like big crates. They were throwing those in there. They're throwing all kinds of stuff like industry trash in there. Soda bottles. They were taking soda bottles or old expired water bottles and expressing all the liquid out of them, using the liquid to create compost, and then burying all the soda bottles in these gravel pits. Wow. And I don't know, honestly, what the environmental impact of that is, but that's definitely something that is interesting and should be looked at. I would think so. Silver Creek, yeah. Okay.
Yeah, now that you mentioned it, in San Antonio too, there are some issues for Martin Marietta and some other companies that are into the concrete business, and they are expanding gravel pits and finding new places, and some of them are awfully close to residential areas. One is right next door to a high school in Helotes, Texas, which is quite unfortunate. Even when I was growing up, we lived about 4 miles from a cement plant, and you'd see that dust on our cars, on certain mornings. And so it is something that we need to definitely look at as far as where they are and be careful about where they expand to, et cetera. It's a tricky thing, but in any industry, anything, you gotta watch out for something.
Yeah. It's a good point.
Mm-hmm.
Excuse me, do you run into issues with codes and requirements in cities when you're building these
Yeah.
Yeah, absolutely.
do, yeah.
No, that's one thing that ECI did in 2018. Every 3 years, the city of San Antonio takes the building code that they want to adopt, and they send it out to the industry. Says, is there any kind of changes or adaptations you want to make for our particular region? And we were given a heads up of that process by a city councilman, thank God, and he said this would be the time if you wanted to make some adaptations to do it. And so we worked very hard to get 9 sheets of recommended additions and modifications to Section 2109 of the IBC, the International Building Code. And we were quite fortunate to be able to persuade the code committee of what we wanted to do to make permitting easier for earth and construction. And that was forwarded to the city council, and then in September of 2018, San Antonio became the first city to seriously modify the building code to make permitting. Yeah, that is one of, it's like a wheel and you got these spokes. Code is one of them, insurance companies are another, lenders are another thing. These people all need to be gently persuaded of the, yes, of the positive attributes of earth and construction. And so, yeah, we're working on that.
Yeah, I think sometimes code officials, they just want assurance that it's not going to fall apart or melt or fall down. We're lucky enough to work with an engineer who stamps all our drawings, and that's a big thing, getting an engineer on board, because as long as an engineer okays it, then he kind of takes the responsibility. And the city can say, like, well, the engineer said it was okay.
Yeah, there's a seal on this.
Yeah. Well, and the engineer knows he's not going to stamp anything that would not, he has full faith in this material. But it kind of depends on the city, who is in the building department, and their openness to it, whether we get any pushback or resistance to it. Some are more open.
Yeah, another thing too, once you get the code revised, interestingly enough, once that was approved in 2018, the assistant director of building services came up to me and says, okay, Stephen, now, 2 weeks from now, if somebody comes up to our desk and wants to get a permit for earth and construction, we need to know what to inspect for. We need to know whether or not their blend of materials is correct or not. What do we do? And so he kind of put that in our lap, and so that's what we're doing now with the grant that we've got for materials testing in order to stay ahead of that too. So when a building inspector goes out to a site, they know what to look for, they know what to test, and any kind of paperwork, it's just an incremental thing.
Yeah, and I'm grateful for what Earth and Construction Initiative does. I think it's
well, thanks
wonderful.
for being a member.
Yeah, I am a member, yes, absolutely.
Yes, you had a question?
What about renovating? So if I have a home that is not earth dependent, is definitely toxic and terrible for my family and myself, but we're renovating or we need to fix something, are there options where we can introduce those more sustainable materials? Or do they not get along?
Yeah, it's one of those.
You
can. There's certain things you can do. A lot of things you can do have nothing to do with earth construction. But the number one biggest crazy chore is what are the toxic and where are they? For example, if you've got wall-to-wall carpeting, that's one of the first things you should get rid of because of all not only the materials the carpeting is made of and the pad beneath, but all the stuff that gets into the carpet and just stays there, cat dander and roach droppings and all that. And so a lot of stuff you could do to, if you know what I know about, oh yeah, if you know what I know about a lot of building materials, you'd be just like, you drive yourself nuts. You can't sleep at night. And so there's a lot of things you can do with that without incorporating earth and construction. And earth and construction, I think, is more cost effective if you're building new. It's really difficult to replace something with something made out of earth. It can be done, but yeah.
It's also heavy, so you have to consider the foundation might not be appropriate. What's there might not be appropriate for earth. But so if you're building addition, it's easy to pour new foundation and footings and build an addition with earthen walls. But one thing you can do, and I was thinking about this, because I kind of anticipated this question. You can use, like, instead of having, paint, you can use American clay plaster. You can have somebody come in and cover all of your walls with the clay, a natural clay, and it's beautiful to look at, and it's a lot healthier to breathe, to be surrounded by it. So that's one thing.
Yeah, it's a great solution. Yeah,
Yeah.
you can do that.
Yeah.
What about swimming pools?
I don't know of an earthen swimming pool, frankly.
Yeah. I like swimming pools. I go in swimming pools all the time. So,
Yeah.
what about salt? We need a salt swimming pool expert to ask that question too.
Yeah.
Have you heard of that?
Oh, no.
Yeah.
Oh, a salt, like an actual salt. Yeah.
Yeah.
I totally want that. Is that my budget?
I know.
But just in terms of the concrete and all that, all the things. There's not a sustainable.
I
swimming pool, is
don't
there?
know if
Totally
anybody's
think
addressed that. It's when we're like I said, when we're doing earthen construction, we're putting Portland in relatively small amounts, and I think once you have to have enough to really counteract the erosion capabilities of water against soil, that you need to have such a high percentage that why bother?
Yeah, there are natural swimming pools. You can. I've heard of it, and I've seen companies that do it, and you put plants and fish, and there's little. It's kind of usually surrounded by a smaller moat kind of around it, and then the middle is the deeper part, and then the smaller moats have lily pads and fish and different things. So
Yeah, it's like having your own little wetlands.
Yeah.
And that actually is what keeps the water swimmable.
Yeah.
It'll never be crystal clear, pure like that or your own swimming pool. But if you can understand that and get around it, it makes a good example. But they're not cheap to put in.
And then I guess in Austin, I'm wondering if there's any possibility of using that technology with the earthen.
Yeah, there's a company out there doing that. I can't remember their name, but absolutely, they're you can 3D print with clay, and you can build a house out of 3D printed clay. The robots that do that, though, they're really expensive machines, and so there's a limit to, because you'd have to move them out into place, because they'd have to build on site. But it's possible for sure.
It just seems cool to have this mixture be able to form at home and have it.
Yeah, there's a place.
Yeah.
There is a place for that. Roland Rael is an architect or designer.
Yeah, that's the name.
He's written, I think, one of my favorite earth and construction books out there. He is very much involved now with robotic earth and construction. But she said extremely expensive, not for everybody, more sculpture than anything else. What we at ECI want to do is make this thing accessible to everybody. We really think that earth and construction, when you consider everything, is the ultimate affordable home and the ultimate starter home. And there's a lot of need for that in San Antonio, as I'm sure Fort Worth and other communities too. So we're really focusing more on that than touting the robotics.
Yeah.
Until it gets bigger and more
Yeah.
accessible, right?
Yeah, I think there's pockets of people who are interested in all kind of different modalities when it comes to earthen construction. It's exciting to see what people around the world are doing in these little tiny sort of pockets.